Hey everyone, I just wanted to thank you all for listening to the Scala logs. I hope you enjoy our first guest, Ross Baker, who is a type level member, HTTP4S committer, Haskell dev by day, Scala moonlighter by night. We'll just get right to the interview. Can you talk a little bit about like HTTP4S, like for our listeners, just like what it is and what it kind of provides?
Okay, so HTTP for S is a library that we started. It was intended to fill a hole that we saw in the Scala ecosystem where there wasn't a very good, strong, functional HTTP library. There are a lot of other web frameworks out there. In fact, I'd written one before. Scalatra was one of my first projects, and I was getting increasingly functionally opinionated at the time, and I noticed that there was a lack of anything that was just on the FP side of Scala. So that's really what we set out to do. It initially started as just a server project, an abstraction over various backends to run servers. And then a little bit later on, it was decided, okay, we could take the same basic model and apply it to clients too. And then from there, the project has grown where we've integrated various JSON libraries, various non-JSON libraries. There are other libraries that are built on top of it. So the ecosystem around it has continued to grow. I think the reason it's continued to grow is just being built on those functional principles. Those are things that snap together nicely. I think that's what permitted it to be a successful set of projects. Basically, that's what we aim to set out to do and are continuing to do.
How did it come about? Like what actually started this need for a purely functional service like this?
Yeah, so as I alluded to, the first web framework that I worked on in Scala was called Scalatra. That's a port of Ruby Sinatra to Scala. That was how I got my start in Scala originally. And I had a lot of fun with that project, but that was about 10 years ago, and I was still coming out of Java Enterprise jobs at the time where I was used to dealing with servlets. I couldn't really comprehend a world where you didn't have servlet containers. So that project is very tightly bound to servlet containers. And that was fine. I was getting a little bit rickety in 2009, but it's totally inappropriate here in 2020. So several years ago, what we decided to do was we wanted to build an abstraction. We looked around, and when you look at the Ruby ecosystem, they have Rack. When you look at the Python ecosystem, they have WSGI. When you look at the Haskell ecosystem, they have WAI. And what all of those do is they provide a fairly simple abstraction. This is how you write an HTTP service. It's just a function. How strictly you define that term function depends on which language you're talking about there, but it's just a function, and you can take that function and you can run it on your choice of web server backends, and you can take your choice of DSLs or frameworks that sit on top of it, and now all of a sudden you've got the Cartesian product of those. You can take any of those frameworks that it supports and run it on any of those web servers that it supports, and that opens up a lot of doors for you. And that sort of thing didn't exist in Scala. So we thought, okay, we're going to abstract away the way that we talk to web servers, and we're going to make that the foundation of Scalatra 3. So that's how HTTP for S was born. Now, funnily enough, what we did was we took this DSL that we found embedded inside of Finagle just as a temporary way of showing another DSL that we could run on top of it. That's the one that's based on partial functions, what you see today as HTTP for SDSL. And that one was just intended as a temporary thing, but that one caught on faster than anything else. And that's the one that people think of as being quote unquote HTTP for S now. There are very few people writing things on things other than that DSL. And Scalatra 3, which was what we started the project for, that one still hasn't come to fruition. Nobody's backported it on top of that framework. So as far as that original idea, that hasn't been successful. But in terms of building that foundation for other things to grow on, that's been wildly successful, I think.
You mentioned that like it's 2020, so Scalatra is probably not the best thing to be using right now. But like, what does the future of HTTP4S actually look like?
So we are imminently going to be releasing version 0.21. That'll get us on Cats Effect 2.0 and Cats 2.0. That's something that people are pretty excited about. So that's the very short-term future. We've got a release candidate that we just released yesterday for that. We will be pushing for that. Maybe by the time this podcast is edited, we'll have that out there in a final release. We'll see. And then I would like to push toward a 1.0. I think we've had a good excuse for not being on 1.0 because we have built on a lot of things that themselves were maturing. When we started this project, there was no cats. We're older than cats. We're older than FS2. We've been through a lot of foundations, and we've been motivated to do releases as the foundations that we chose to build on changed. We've had to do releases in response to that. But now those things that were built on at our core, CATS and CATS Effect and FS2, those are all up to 1.0 or even 2.0 status. CIRCE, which isn't a core dependency, that one's nearing 1.0. So we're running out of excuses to not be 1.0 ourselves. We've been doing this for a while. We've learned a lot of lessons. So I'd like to get that stabilized and have that 1.0, just that version number that makes people feel good about the project. People have been using HTTPS in prod for a long time. They shouldn't be scared off by that 0.x. There's a lot of good software out there that's 0.x, but I know people get hung up on those version numbers. So getting to that 1.0, I think, is going to be the next major step for us.
Yeah, I think that's great. So for HTTP4S, the representation of a service makes HTTP4S actually really easy to think about. Can you talk about the internal representation?
Sure. So the foundational principle on it for an HTTP app is it's just a function, basically. There's some fancy type wrappers that go on top of that, but think of it as just a function where you've got a request that comes in and you've got an effect of a response that comes out. And when we say an effect of a response, I'm talking about anything that implements the CATS effect type classes. So typically IO is the one that people most commonly use. The reason that you have IO there is it's an asynchronous framework. Like I said, we've learned some of the lessons from servlets. Servlets traditionally are a synchronous framework, and they've got their own async abstraction at this point. But you think of that as being synchronous. We want to be asynchronous. So you go from a request to an IO of a response, basically. And there are some type wrappers on top of that. So we wrap everything in a Kleisli, which helps things compose a little bit better. There are some monad transformers in there, which are helpful for routing. We could go on and on about that. I gave a talk at Any Scala a couple of years ago. There's a video out on YouTube where I explain the differences between being just that simple function and the signature that you see today. So it's a little bit more complex than that. But at its heart, it's just a function. This idea of your server as a function is a really powerful thing because that means you've got all the capabilities of functional programming with composition. Those become available to you. One door that opens up for you is this concept of middlewares. All a middleware is it's a function from an HTTP application to another HTTP application. And what can those middlewares do? Well, they can do things like compression. So you can look at the headers and apply gzip compression to the bodies, either on the request or the response. Or you can implement the HTTP head method. That's another one that we have, where you can implement that in terms of a GET, but you can modify the request on the way in, pass it to the inner service, and then strip the body on the way out. There's all sorts of functionality that you can build there in terms of these composable middlewares, and you stack those together. And by stacking those together, you're able to pull that out. Things that you would typically rely on the web server backend for, you're able to pull those out and make them available to everybody and also reason about them in a functional way. And it just provides a more cohesive ecosystem across the board when you're able to do that. So I think that's one big advantage to having the HTTP as a function. And the other big advantage to it is testing. I think that's so much fun. I think back on when I got started doing enterprise development in Java, we had this thing called Cactus, where when you wanted to talk to a server, you ended up talking to a servlet container via RMI. So it wasn't quite talking over HTTP. It wasn't doing anything local. It was kind of the worst of both worlds there. That's how I used to have to test web applications when I started developing things, because you needed to introspect into the servlets. It wasn't quite white box testing. It wasn't quite black box testing. It was a real nightmare. It's so nice when you've got HTTP as a function, because in your unit test, you can pass in a request and you can do assertions on the response, and you don't need to worry about the transport. It makes the tests run a lot faster. It's easier to run them. And then you can write a few integration tests at the end and really test your HTTP layer. It just simplifies the testing story a whole lot, though, to have it as a function that you can run and just inputs and deterministic outputs.
Yeah, I mean, being able to create clients from your servers also is extremely nice for testing.
Yes. Yeah, we've got this method on there, client from HTTP app. So that's essentially your way of having a mock client rather than using a library like Mockito or something like that you might have to use in other libraries. You can just come up with this function, which is how your client is supposed to behave, and then you can pass that around and test your other logic and test your happy paths and your unhappy paths. It's really convenient.
So we've kind of talked a little bit about the internals of HB4S. What advice can you give to people that want to help out, and like how can they get started?
Great. So, one thing that we've been trying to do a better job of lately is start tagging things as good first issue. I just did that a few days ago, and we had a first time contributor jump on it right away and came up with a great pull request for us. Yeah, be on the lookout for those. We're very anxious. If you look at our issue queue right now, we've got 200 issues out there. Um, we're anxious to have the help. There's always work to be done, even though it's a fairly mature library at this point. There's always things out there, and we like fostering those new contributors. That's something that's very rewarding to me as a maintainer, is helping these people get started. Because a lot of these people that submit one, they tend to be the ones that end up submitting more than one and eventually go on to be committers. And yeah, that makes things better for everybody. So we're going to try to do a better job of tagging those good first issues. Just jump in, don't be shy about it. And another thing is maintainers get a little bit busy sometimes. I think we don't always keep that queue of good first issues as full as we should. Just come into the Gitter channel or tweet at us and volunteer and say, hey, I'm interested in helping out. What can I do? Because I think we're all going to be so excited to see those new volunteers stepping forward. Whenever I see somebody say, hey, I'd like to help out, but I don't know where to start, that motivates me to go and make sure that there's a good issue for them to start on.
Yeah, I'll make sure that we have links as well
Okay, great.
down for everyone. What do you enjoy doing with your free time outside of programming?
Excellent question. So when I have free time, I love programming more than anything. So I find myself, even when I have free time, I'll program, but I'll program in other things rather than doing something specifically for my day job. Like I have a lot of interest in sports and I have a lot of interest in statistics. I think, oh, I can do some sports analytics on this and I'll go off and learn R, even though I'm not a data scientist. One weekend I taught myself some R to scratch an itch. So unfortunately, I'm a nerd at heart, and I love to do that kind of programming, even when I'm not on the clock and not doing my open source. I still do that sort of thing, but it's a tedious life if you're always at the computer. So I'm also an animal lover. I have a dog. I have two cats. I have 5 freshwater fish tanks around. Never gotten into saltwater because between the dog and the cats and 2 kids, that's a lot of work. Saltwater tanks are too much work, so I do freshwater. That's easier. Yeah, spend a lot of time on the pets. Also, like to spend time with the kids. Any common interests that we have, I like to foster those. I think that's what really helps you spend the quality time with your kids. So, my daughter really likes soccer. I really like soccer. So, I've stepped up and I'm a volunteer coach. I coach her U12 soccer team. Have a lot of fun doing that as well.
Awesome. Yeah, I think it's really important to have hobbies outside as well, just so you can appreciate programming and that other side as well.
Right.
Can you talk a little bit about your experiences at Verizon with the Scala team you were on?
Oh, yeah. That was just one of the most thrilling experiences of my career to be able to work with some of those big names in the Scala community. I hesitate to name drop anybody. Most people know who they are, and I'd leave out so many because there are so many good people there. It was really exciting being at a place that was held up as a success of this is how Scala can be wildly successful in the enterprise. It was a company that a lot of other companies wanted to emulate, and being part of that was just such a thrill. And even though I left there a couple of years ago, people still refer to some of the things that we built at Verizon. The Nelson project that I worked on there that has continued to be used by several companies, continues going strong. There's conference talks about it. So seeing some lasting legacy that came out of that has just been really exciting as well.
Was Nelson your first like foray into infrastructure, or was it before that that you had started building tools for that?
That was my first foray into infrastructure. Yeah, I'd never been on an infrastructure team before I was at Verizon. I went there because I was interested in Scala and FP, and nobody was doing Scala and FP better than they were at the time. And there was an opening on the infrastructure team, and that's how I got into infrastructure. And oddly enough, I'm on an infrastructure team now, but I'm not doing Scala right now professionally. So it ended up opening a door for me so I could go into something else. So at this point, I love Scala FP and I love infrastructure.
Can you talk a little bit about your first introduction to programming?
Oh, yeah. Um, so I got started programming probably when I was in about kindergarten or first grade. My aunt was a DBA at the time, and she got me a book, Programming Tandy Basic, and I just wore the cover off of that book. writing basic programs. I just captured my mind when she got me that book. And then I had this magazine back then. There was this magazine called 321 Contact. And at the back of the magazine every month, there were these program listings in BASIC. And I guess floppy disks were too expensive back at the time. There were no CD drives at the time. So to try these programs, what you had to do was you had to just sit there and type the programs out of the back of the magazine and enter them in. And you do that and run it. And then I would start to take them apart, disassemble them, see how I could make them better. That's how I first started programming. Just been doing it from an early age. I ended up having that computer for a very long time, funny enough. I mentioned I'm also interested in sports. So I had this hockey game that I really loved. And I wanted this expansion pack that went along with the hockey game that would let you manage your rosters, sort of be the general manager of things, almost like a hockey tycoon type of game. Except my computer was too old. It wouldn't run that game. It ran the hockey video game part of things, but it wouldn't run that other engine. And I was very disappointed. I really wanted to have that software, but I couldn't do it. And I started poking around at the data files on that, and I saw, okay, well, here's the names of all the hockey players I know, and then there's all these numbers after them. Hey, that's their jersey number, that's their skill levels in the game. And just by poking around those data files, I figured out what the data format was on that. And I ended up, because BASIC was the only language that I had at the time, I wrote this application in BASIC because I couldn't go out and buy that game that I had. And because I was a kid and had all the spare time in the world, I was able to essentially rebuild that software that I couldn't go out and buy and run. That was probably my first real substantial application.
I think that's a fantastic first substantial application.
Yeah, it's unfortunate I'm so old and we didn't have GitHub at the time. I would love to have that source code and see what kind of code I was writing when I was 10, and BASIC was the only tool that I had. Unfortunately, that app is lost to the sands of time.
How did you start in FP?
Great question. When I was in college, I went to Indiana University. We learned primarily in two languages. We learned in Java and we learned in Scheme. And Scheme is not typed functional programming, but it has a lot in common with functional programming in terms of favoring immutability in a lot of ways. It's not as puritanical about it as some FP languages that we use today, but certainly more so than Java or any of the other languages that I were using at the time. And it also supported the idea of higher order functions. So you take a function and you modify that function as an argument and pass it somewhere else. I think that's where I first got the FP bug. And then after I graduated from school, there's obviously a lot more jobs in Java than there were in Scheme. So I ended up being a Java programmer professionally. And as I got to be a professional programmer, I really saw the value of types as I started to work on these bigger applications, even bigger than that hockey hack that I wrote in BASIC so many years ago. I really saw the value of types in that, but I really enjoyed my Scheme experience and the FP as well. And several years later, I came across this language called Scala, which looked really compelling because it was focused on FP just the way that Scheme was, but it was focused on static typing just the way that Java was. And putting those two together, that really lit me up. So I started teaching myself Scala in my spare time. And that's how I really became a serious FP developer.
You'd mentioned learning Scheme in college. Was that a worthwhile investment for you?
College was absolutely a worthwhile investment for me. When I came to college, the only languages that I knew were BASIC, and I taught myself Perl in high school. Those are the only languages I learned. Being able to sit down there with just some really brilliant minds and learn the nuts and bolts of computer science. I think learning a language like Scheme, even though I've never been paid to write a line of Scheme, that foundation that I got has helped me acquire all these other languages that I've been able to do faster than I would have been able to do otherwise. And in addition to that, it was a really worthwhile experience for me, just growth as a person, getting into new interests altogether. To satisfy a humanities credit, I took this class, The Music of Frank Zappa. And by the time I was done with that class, I had 20 Frank Zappa CDs and just adore his music to this day. That's something that I never would have really gotten into had I not had that exposure. So I think it was really good for me, both as an engineer and as a person. Probably most importantly of all, the first night I was there in college, I met the woman who would become my wife. So I owe a lot to that experience, and I continue to speak highly of it. At the same time, I don't think it's necessarily the right thing for everybody. I get tired of these battles that flare up on Twitter where people say, oh, you have to have a college degree to be a good engineer, or no, it's totally worthless. And I don't really think either of those extremes are true. I wouldn't be the person that I am today without that experience. I'm so glad that I did it. Some of the best engineers I've ever worked with, though, didn't go to college or 100% self taught, and I think it would have been a waste for them. So I would say college is not necessary. It's not sufficient, but at least in my case, it was really good for me. I think there's a lot of paths to success in this industry, and we shouldn't rule them out.
Yeah, I think the conglomerate of experiences that you get out of it is worthwhile to a lot of people for exposure.
Right. Yeah, I would recommend it to anybody, but I would also not turn my nose up at anybody who took a different path because I know a lot of wonderful, interesting people who took other paths.
How did you actually get started in Scala professionally?
So I mentioned there that I was interested in Scala on a hobby basis, just trying to mix the types and the functional programming. And this was back in 2009. The only web framework that was out there was Lift, which was interesting work. It was innovative, but it didn't really do things quite the way that I wanted to do things. That's when I got involved in Scalatra. I had my eye on Ruby projects at the time. I was going through a bit of a Ruby phase. So I started work on Scalatra. And then as I did that, there was a startup out in California that was still in stealth mode, a nice black and white website. And the director there is like, hey, I've been using Scalatra at my previous work, and we're starting up this company, and we want to start building some web services on that. And we'd like to hire the open source developers. We want to hire the people who built the things that we want to build on. So I took the leap of faith. I'd never done the startup thing before. I live here in Indianapolis. I've been mostly doing enterprise kind of jobs because that's mostly what we have here. That was my first experience in the startup and first experience doing Scala professionally. Got my start there and have been fortunate to be doing Scala or FP ever since.
Yeah, that's great. So, can you talk about your experiences with remote work then? You said you live in Indiana right now, and I know you've worked all around the United States essentially.
Yeah, so remote work is wonderful. I've on my fifth remote job in a row, sixth remote job. I've lost track at this point. It's been a really comfortable fit for me because I know you're also a Midwesterner. I don't need to sell you on the Midwestern life. Might need to sell a lot of our audience on that. But I really love it here. I don't want to move. But at the same time, it's really exciting to be able to work with people who don't want to live in the Midwest. So we're frankly in a little bit of a niche here, being FP people. It's a smaller community. So being able to do things remotely within that small community, that makes it feel like a bigger community than it is. It helps establish connections. So I think it's really the best of both worlds, where I can live here, where I'm fairly close to my family. Whenever I do change jobs, I've just recently moved from a West Coast based job to an East Coast based job. I didn't have to uproot my kids. They're still in the same school with their old friends. That's really nice. Just having that freedom to decouple geography from the work that we want to do is so empowering.
Yeah, totally. I mean, not really talking about remote, but talking about just open source and like getting people to see FP. I would have never known that this level of FP existed without open source. And like, I mean, my first introduction was Scala Z.
Right. Yes, I think the open source has been something that's been important in terms of the remote work. Had I not gotten into Scalatra, I wouldn't have ever been noticed by that stealth startup in California and wouldn't have gone on to do the other fun things that I've been able to do after that as well. I've been lucky to be able to contribute to open source. I think if there's anybody out there that's wondering, okay, I'm really excited about Scala, I'm excited about FP, but I don't know how to get noticed. I think contributing to open source, even though there's a little bit of sacrifice involved in that, it's a really good way to do it. It's first of all, it's rewarding in its own right. And second of all, I think that's how people get noticed. If you're not in New York, if you're not in San Francisco, if you're not in London, if you're not in one of those major tech markets, it's a way that you can get your name out there.
So, what have you been learning lately?
So I mentioned I'm not doing Scala professionally right now. I changed jobs back in October. Went to a company called Earnest Research, where I'm having a great time. They're primarily Haskell focused, and I still love Scala. I'm still contributing to Scala in my spare time, but I've been looking at Haskell here for a long time and wanted to get into that when I had the opportunity to do so. So I've been ramping up on Haskell. I've read the books on Haskell. I learned a little bit of Haskell several years ago as I was upping my Scala FP game, because there was a time there where all the reference materials for FP in Scala said, okay, go learn Haskell, read about it in Haskell, and translate back what you learned. Fortunately, I think with some of the things like the type level ecosystem, putting so much effort into documentation and being friendlier and just a bigger ecosystem, people like Underscore putting out really good books and training materials, the situation's a lot better there than it was. You don't have to learn Haskell to learn Scala anymore. I still think it's an interesting thing, though, because that's a very innovative community, and I wanted to spend some time in it and see what life was like outside the JVM. I've been on the JVM professionally for almost 20 years now and wanted to try something a little bit different. So ramping up on Haskell is part of that job. And I mentioned to learn Scala back in the day, it seemed like you really had to go off on this detour and learn Haskell to do Scala FP effectively back then. And as I'm learning Haskell now, I'm finding it increasingly to be the case that to do Haskell effectively, you have to go off and learn Nix. Nix is a packaging system, which isn't mandatory for the Haskell ecosystem, but I think it makes things a lot easier in terms of having distributed builds and just a package that you can clone and have everything work. We're fairly spoiled in the Scala ecosystem because most things run from SBT and you just fire it off, and almost everything is contained in the JVM, where whenever you leave the JVM, that's not necessarily true anymore. And I think Nix fills in that gap very well. So I've been learning a lot of that as well. I've probably written more lines of Nix than I have in Haskell, despite being anomaly, a Haskell engineer.
Can you talk about Nix a little bit? Like what problems it solves for us folk that aren't in the Haskell ecosystem?
Sure. So Nix is not specifically bound to Haskell, although it seems like most people I know who are excited about Nix are also excited about Haskell. It integrates with several of the major Haskell build tools out there. Like there's a stack integration, so you can get your packages for stack via Nix, or you can have Nix be the outermost shell of your build. That's something that I've been doing a lot of work on, where you invoke Nix builds directly. And the nice thing about it is Nix is based on this idea of reproducibility and hermeticity. So it says, okay, if all of the inputs are the same that go into this build, I know that I'm going to produce the same output. So it hashes the inputs that go into it, and you can cache that output. And what that gets for you is it gets you a distributed build. We're using this really nice service called Cachix. So anytime we build something, we are pushing the results of it to Cachix. And what that means is that when our CI system or one of our developers checks out a new version that forces us to rebuild a lot of these big heavyweight source dependencies, we've only got to do that once. We push it back up to that distributed cache, and the next person who tries to build the same thing is going to be able to fetch the result of that from the cache and not have to rebuild that. And that's something that's huge in the Haskell ecosystem. We're used to in Scala, we've got binary dependencies. We don't need to recompile the whole world. But when you're in the Haskell ecosystem, most of your libraries are coming in as source dependencies. And even worse than that, sometimes your entire tool chain is a source dependency if you're using patches of that tool chain, which is a pretty common position to be in. So you end up recompiling all of GHC, and if you have to do that, well, you better start it and then go out to lunch, and you can go have a nice fancy lunch because it's going to take you a couple hours. So having a cache for that is just a huge productivity boost in that ecosystem.
Awesome. Thanks for that explanation.
And it goes beyond the building as well. So I've taken it to the next level. All of my dot files are maintained in a Nix repository, and that's a really powerful thing as well. What that gives you is I've got multiple machines. I've got my work laptop, I've got my personal laptop, I've got a Chromebook I take with me when I'm really portable and need that extra battery life. And what I'm able to do is I'm able to store my entire configuration in Nix. And that's not really that innovative. A lot of people, they've got a dot files repository out there to achieve mostly that same thing. What's exciting when you migrate all of that to Nix, though, is you've got a programming language for that, because what you'll usually find in those dot files repositories across machines is, yeah, 80% of the dot files are the same, and then 20% of it, it's you need something a little bit different from host to host. And having a programming language to tie all that together really makes that click.
Yeah, that's actually really interesting. Maybe this is the same thing, but what's an important subject that you think everyone should know?
I wouldn't really necessarily point to any one particular subject. I think what's important is that you not pigeonhole yourself into one technology. So I've been identified as a JVM developer or a Scala developer here for such a long time, and I still love both of those things. I think it's good, even though I've been doing this here for 20 years professionally now. I think it's important to keep learning new things and push yourself outside the comfort zone. You find that you'll pull in things. Even if I go back to the JVM, I'm going to take things that I've learned by getting off of the JVM for a while. So I don't want to point to any one technology that everyone should know, but I just want to remind people, even old people like me, don't get comfortable with what you know. It's good to take that leap of faith like that and jump into something completely new. I think it keeps you sharp as an engineer.
Do you feel like your jump from a applications programmer to infrastructure engineer has helped that a lot?
I think it's helpful, and I think something that helped me as I did it was I controlled the dimensions that I was changing in at the time. So I started as a Scala F- FP engineer for applications, and then I swapped out application engineering for infrastructure engineering, but I was still in my comfort zone with Scala FP. And then a little bit later, I swapped out the Scala FP for Haskell, but I'm still in my comfort zone as infrastructure. If I had gone from Scala FP application engineer directly to Haskell infrastructure, then I'd be learning two things at once. That can be a little bit difficult. So I would encourage people to get out of their comfort zones, but if they can do that incremental kind of thing where they maybe step in one direction and then take a left turn or a right turn and then go off in a different dimension and learn something that way, I think that manages it from being so overwhelming and you're able to contribute to your team at all points along the way. I'm glad I was able to take that progression as I've evolved.
Is there anything that people should be using that you feel like that they aren't at this moment?
One thing that I'm excited about that I don't have a great deal of experience yet, but I'm seeing my teammates using, and I'm seeing some of the code that it's replacing, is DAL. That's DHALL. I'm excited about that. Being an infrastructure engineer, that implies just a ton of YAML. And I don't want to rag on a technology, but writing reams and reams of YAML isn't really the most exciting thing in the world. And there's a reason for that. It's you have a whole bunch of YAML, you get a lot of repetition in your YAML, and you think, man, I wish I could dry this up with some sort of rudimentary programming language. So you want to have a templating language or something like that. And a lot of people, they will solve that problem by saying, we're not going to write things in YAML, we're going to write things in Scala or Haskell. And I love Scala and I love Haskell, but that's a lot of power for configuration and you're able to do side effects inside of those, and that's not necessarily what you want to do in configuration. That's almost too much power, where YAML's not powerful enough. And somewhere in the middle is this language called DAL, and DAL is limited in terms of, as they like to say, it's not a Turing complete language. There's a guarantee of totality on it. You know that your programs are going to complete. They're restricted in what they can do. One of the implications of some of that is that you don't have recursion inside of that. So it puts some limits on what you can do, but it's a very powerful typed language in its own right. So what we're able to do with DAL is we're able to generate our configuration. You can take DAL expressions and you can generate those directly into JSON or directly into YAML. You've got a programming language that goes with that. You've got types. We all love types. You've got types that come with that, but you don't get too much power. You don't get all the power of Scala or Haskell where you can really shoot yourself in the foot on configuration. It's this really exciting language that sits in that middle ground that I think is missing for when you're doing a lot of configuration but don't want to go too far with it.
All right. Thank you, Ross, for being with us.
Yeah, it was an honor to be here. I really enjoyed it. Thank you.
Thank you all for listening. Please subscribe and follow the Scala Logs. It means a lot to me to see you all listening. If you'd like to contact Ross, you can contact him through Twitter and Gitter. I'll put those down below. I'll see you all soon.